Okay, this is lesson 2.2e. This time, I'm on number 4. This is the second part. So this time all we get is the graph. Um, so when I get the graph, I'm going to go to the equation first. So here's our format that we need. So somehow off the graph we need these two things. We need the rate of change and we need the initial value. So the initial value is right here where the line crosses the y-axis. So that's 100. And the rate we get by our graph. Now be careful with the intervals. Remember, here we go down 10, but we go right 2. So we have y over x. So we have negative 10 over 2, which will give us the rate of negative 5. If you put all this stuff in the equation where it belongs, you have y equals negative 5x plus 100. Okay, so to fill in the table, we know that this initial value occurs where x is 0. So we don't even know what these are yet. We didn't make up our context. So x is 0, y is 100. Okay, so when x is 1, or you could go by 2's like the graph, it doesn't matter. When x is 1, you're going to take a 5 off of the 100. So I'm going to be at 95 because your rate is negative 5. At 2, I'm going to be at 90, 5 less, 3, 85, 4, 80, 5, 75. The rate is minus 5, 6, 70. So now you have to write your context for this. Let's say, let's go back to the bank account. Joe has $100 in his bank account. And he spends $5 each day on Starbucks coffee. So let's go back and label the graph. This would be savings, and this would be days. So let's label this days and the amount of money in savings. Okay, that money's going to go quick. All right, let's answer the questions about this now. A says, what is the rate of change in this problem, and what does the rate of change represent in this context? Well, we identified the rate of change as negative 5, and 5 is the cost of a cup of coffee. What is the y-intercept of your graph? Where do you see it on the table in the equation? And what does it represent in the context? Well, we said it was 100, and that's the amount in Joe's savings to start. On the table, it's paired with a 0x value. Go back and show you. It's right here where x is 0, your y-intercept is the y value paired with it. And on the graph, it's right here. The place the line crosses the y-axis. Okay, how could your context and equation change if the y-intercept of the graph was changed to 75? So down here. And how would this affect the graph? Okay, so it would really, the graph would just move down. The rate would stay the same, but the graph would move down. And how would you change the context? Well, he would only start with $75 in his account. Letter D, how would your context and equation change if the rate of change in the problem was changed to -2? Would the graph of the new line be steeper or less steep than the original? Well, I think we have to go to Dunkin' Donuts instead of Starbucks. So the cost of coffee is $2 now. We're going to Dunkin' Donuts. And the line would be less steep. Coffee is cheaper. Okay, let's move on to number 5, the last one. This time, we get only the equation. So I'm going to go to the table first. We'll go back and label after the context. So we start at 10. That's right here. That's our B. Now our rate is right here. It's +4. So we're going to add 4 every time. So at 3, we'll be at 22. 4, we'll be at 26. 5, we'll be at 30. And at 6, we'll be at 34. So, you know what? I'm going to get some context with that so I know how to label everything. You could do the graph first, but I'm going to get some context. So, I collect stamps. I have 10 now and plan to add 4 more every month. So here is months, and here is number of stamps. So months, again, I can't label the bottom just like before. I'm going to go by 1 and the months, but here I'm going to go by 2. Okay, when I plot this, I'm going to start at 10. And every month, I'm going to go up by 4. Use your rulers. Okay, there's my graph. So I can go ahead and label my table now because this is months and this is number of stamps. Okay, all right, let's answer these couple last questions. Here's your equation. Your original is right here. How would you change the context if the equation above was y equals 2x plus 10? And how would this affect the graph? Okay, so instead of adding 4 every month, I plan to add 2 every month. So the line would be less steep. The rate of change is lower. How would your context change if the equation above was y equals 4x plus 8? And how would this change your graph? So I start with 8 this time. So the graph would be at the same rate of change, the same angle, but it would start lower on the y-axis. Okay. So in your own words, I want you to take a minute and describe what a linear relationship is composed of. Think about all of the equations that you've written in the past couple of weeks. What do they have in common, and what do the different parts represent? We have talked about this like 1.5 million times. This is what your equation looks like. You're going to need m, or the rate of change, and you're going to need your b, which we have heard referred to as a couple different things by now. First, I talked about it as a starting point. We've also referred to it as an initial value. And now we're beginning to refer to it as the y-intercept, or the place that the line crosses the y-axis. These are all things you need to know. That's it.